also look at this in another way, right? So the learning objectives here will be to apply data cleaning techniques like missing values, outliers, data types, conduct exploratory data analysis using visual and quantitative tools. Instead of you writing a lot of your own data, I want us to just use some, existing methods to do this very quickly. Understand data distributions, relationships, and correlations, and then we'll use Python libraries like Pandas, Matplotlib, Seaborn for our exploratory data analysis tasks. So essentially, what is data cleaning? Data cleaning is the process of correcting or removing inaccurate, incomplete, improperly formatted, or duplicated data. In this section, we would apply essential data cleaning techniques such as handling missing values, fixing data types, detecting outliers, and preparing data sets for analysis. The exercises are project-based, and they use a real-world data. You're going to see that, and that's the Titanic data that we mentioned earlier. That's what we're going to use here. So common cleaning steps will be, we want to handle missing values like with using these methods, drop NA or fill NA. This helps you drop missing data. This helps you fill it up. We want to correct data types. If a data type is one form and we want to move it to another form, say I have a text data and I want to convert it into, I have some text data and I want to convert it into dates, some kind of dates data, I can use all of those. Or if there are duplicates, I want to drop those duplicates, I can use drop underscore duplicates. Or if I want to strip white spaces, there are some white spaces in a text. This is what I use, a method like this. And then if I want to handle outliers, and I can use our IQR filtering and Z scores. So these are statistical tools here, right, that you can use to filter or handle outliers. So what I'm doing here is I'm importing Pandas, which is one of the Python packages, as PD. In other words, I want the shortcut to be this, and I'm loading up my data right now. I'm loading up my data directly from a URL, and this is the URL. This is actually a Git. I think this is coming from a GitHub. If you copied it, let's see what we have here. So this is what the data looks like, right? And it's raw data from a GitHub, but we want to go ahead and just load it up here. And then once we do that, we want to convert it into a data frame. That's why you have your pd.read_csv, and then you put in your URL here. And then after that, we want it to print out the head, which is typically like 5 rows. It's more than 5 rows, and you're going to see that. But if you don't put anything, the default value here is 5, but I can decide to put anything there and get more. So if I run this, it's running. So this is what I have. So let's see if I want to see some more. I can just say, let's make it 50 rows, right? I run my 50. Now all of a sudden I'm seeing the 50 rows. So we can see, and this is real life data of the people that were involved in the Titanic incident. So we have the passenger ID. We're trying to figure out whether they survived or they didn't survive. 0, 1. What passenger class they were on. There were 3 passenger classes: first class, second class, third class. So this fellow was in third class. His name was this. His sex was this. His age was this. IBSP. Not sure what that is. Let me check that up. In Titanic dataset. So this is what it was. Oh, sibling. In this famous Titanic, SI BSP represents the number of siblings, brothers or sisters, and spouses that a specific passenger had on board. So this guy had one other person that is their family on board. You know, this is their ticket number. This is how much they paid. You see, he's in third class. That's why he was paying seven. Probably this was dollars or pounds, 7.2. So this other person was in first class and they paid $71. So that's the difference. And then this is the cabins where they were. We didn't know where this guy's cabin was. You know, the other thing we want to check was embarked in the data. And this is why you want to when you get your data, you need to be able to put all of that meta information about the data so that someone can just look at the data and see everything that's there. So embarked column indicates the port where the passenger boarded the ship. It contains categorical values mapping to 3 embarkation ports. So they got on this at 3 different ports, right? Southampton, Cherbourg, and Queenstown. So notice, so look at the various things. This is Queens, Southampton, and Cherbourg. So those were, it depends on where you embarked. So the important thing is to understand what all of this data is. So if we want to find the tail, we can also do the same thing. We'll say tail, df.tail. Let me just df.tail. You know, let me just remove this temporarily and then just run this. So that's the lower part of that data. That's how you get your tail, right? So let me remove the 50. Let's go with our normal 5. So I run this and I still have my 5. So to understand the data, all we need to do is say print df is our data. Remember, this is the data frame that we created. If I say .info, is going to give me information about the data. That's the first part of that printout, right? So it's giving me that on the passenger, where is it? The passenger ID, that there are 891 entries. Survived 891. 891, that's the data on this column, not the number of people that survived, the data, the number of data on that column, 891. So let me check the survived, what the 0 and 1 mean in survived. So zero or one in the, oops, no, sorry. Right? So in the Titanic data set, survival is recorded as a binary value. 1 means the passenger survived the disaster, and 0 means they did not survive. So if we go back here, right, that means this guy did not survive. Why? Because in survived, he was 0. So notice all these other people that are in, okay, this person is in third class, also survived. Probably because she was female and maybe they were letting a lot of the females go first. So again, that's how to understand this data, right? Then these are the entries. So when it comes to the age, notice that 714. So it seems like there was a lot of missing data on the age. There were a lot of people we didn't know their age or something, or the ages were duplicates. You know, there were multiple people, I don't know. And then the cabin, there were 204 cabins, embarked 889. So missing values, okay, you can see it when you come here, age 714. That means there were about 177 people whose ages were missing. And then there were 687 whose cabins were missing. And then how did we do that, right? To do that, we just said df dot is null. In other words, it's null dot sum. This is finding the number of is nulls. So the question is, what is null? Because we already know what df is, right? So we go in look dot is null. See, most famously used in Python pandas to detect missing or undefined values. So that's how you detect it. So once I've detected it, I want to know the sum, how many of them are there. That's how you arrive at this, and then you print it out. And that's how we ended up with this. So even without interrogating the data directly, we have information about all of these things. So how do I now handle missing data, right? That's the step 3. We impute data with median. So if we come in here and we say if age in df.columns, right? Now df for age, just by doing this, I'm isolating that column on age. Where is my age? Yeah, I'm isolating this column. When I say df and I put it in square brackets and I'm essentially isolating, I'm saying I'm focusing on this. I'm essentially creating that will be equals to df.age.fillNA. In other words, fill NA, right? I'm saying anywhere I find, remember that fill NA helps you fill anywhere you see a missing value. Please fill it in with something, right? Look at it. You can customize exactly how missing data is handled using the following parameters, so that's how you choose how to fill up that thing. So what did you decide? I'm saying that everything on that column, and I'm going to find the mean of it. That's how I'm going to fill anything where there is a gap there, you know. Then we do the same thing with in back. What we said is use mode. We can't use median because these things are letters S, G, and C. The reason we're using mode is the one that appears the most time, I believe. That's what your mode is, right? But we can't take the average of letters. So we use that to fill in embarked. Remember, embarked is the station where they got on. Then the next thing I want to do in cabin, I said df.drop, see what the drop does for you. The drop in pandas is used to remove specific rows or columns from a data frame, So essentially, it seems like they are trying to remove the data frames that have missing things in their cabin. And then the missing values dot null, we want to figure out how many missing values there are after I've done all of these things, right? I think it's like a double check. So this is what you have. Missing values after you have done all the cleaning, right? You've done all this cleaning. I want to find out if there are any missing values, and we can see there are no missing values, right? No more missing values because of all these things I did here. Fixing the data types, right? So are there issues with the data types? That's what I want to find out, D survived. I'm focusing on the column called survive, and I'm saying D survived dot AS as type. In other words, I'm trying to change the data type to category. You do the same thing with P class. So let's go again so you can see. I think I mentioned this already. What the D class, D type. type, the primary method used to explicitly cast the data type of a data frame to a specified format. So I want this data type to be a specific type of data type. That's what you're doing here. So I want these to be categories, and there's good reason why I want them to be categories. Why? Because the class that you are in is 1, 2, 3, survived is 0, 1, right? So they are essentially categories. Convert tickets to string. So anything I see in under tickets, I want it to be string. Let's go back and see what our tickets look like. So you see, so I don't want a situation where this will be reading like a number, because we are not going to manipulate this. So I want everything here to be considered as a string, anything on this ticket. Yeah. Because if you don't do that, it might just mess up your analysis. So when you do that, then you run this, and for both of them, you are now seeing that they are specific objects or categories. You've stated it the way. And then now you want to detect the outliers, figure out what the outliers is, and then you use Seaborn. Seaborn is essentially one of those tools. Seaborn and Matplotlib, right? Those are both packages that you essentially use for visualization. And what you want to do is, visualize this and see what you find here. Remember, I talked about IQR. This is essentially a statistical tool to help you figure out your various quantiles, right? Because all you're saying is your Q1 is your 25th quantile, your Q3 is your 75th quantile, your IQR is your Q2, Q3 minus Q1, right? Which is going to fall somewhere in the 50th quantile, I believe. And then this is your lower quantile. This is your upper and lower values. And then you can now use that to manipulate your data. And then that's how you arrive here. So when we plot this, right, all of a sudden we can see that this is an outlier. So let me see. This is where you now remove your outliers. Your DF is equals to, you're talking about your fare is greater than or equals to lower. So this is the condition for which, if this is this and your fare is lower than or equals to a certain value, right? That's how you restrict. In other words, anything that doesn't fall within that range is no longer in your data frame. We plot it, and this is what we have. And then look at your data has been reduced to 775 rows, 11 columns. So we now try to describe, just like your .info. This is your .describe, where it looks at every. So let me do both of them. So after that, let me do .info first. .info, let me run .info. Sorry, I have to. So this is your .info. Essentially, it gives you all of the information. The summary starts on each of this, but then this is what describe does. Describe goes in there to go give you each column how many rows there are, how many unique values. There are no unique values, the mean, the standard deviation, everything for each of this. So for example, where would the top value, frequency values 531, so there are duplicate ages and all of that. So I am going to probably stop here, and I would want us to go ahead and play around with this. I would upload this. This is essentially the part about the EDA, exploratory data analytics. So I would have you play around with those. Questions? Does any of you have a question? Because essentially we've been able to do most of the cleaning today. For you, the next step will just for you to do the exploratory data analytics.